Braylon Watt, coming to you with a super special report on heat transfer. Heat transfer is something we experience in our everyday lives. Do you want to cook pizzas fast?
Yeah!
Use a convection oven. Do you want to tan for the summer? Lie out on the beach and experience radiation, but don't forget that SPF 30. Now over to Haley, an inexperienced high school student with an explanation and demonstration of conduction.
Conduction is the process of heat transfer through contact. When one object makes contact with another, the heat from one object will transfer to the other. Some materials make better heat conductors than others, such as metals. When an object is heated, the particles will gain more kinetic energy and begin to move slightly and vibrate, which allows the object to gain heat. The high energy particles from the heated object will bump into the particles on the object that is in contact with the heated object. This allows the energy from one object to be transferred to another object in the form of heat. The following experiment shows how conduction works in metals. The heat from the candle travels from the center out to the different types of metals. The different metals will be more conductive than others. You'll see the metals with high conductivity melt the wax faster than the metals that aren't good conductors.
Ow!
Be careful! Don't you remember when we learned about conduction?
No.
Metals are really good conductors. Use an oven mitt.
Okay, thanks. Ow!
Ian! Thanks, Haley. Now on to convection with Ian.
Convection is defined as the transfer of internal energy into or out of an object by the physical movement of a surrounding fluid that transfers the internal energy along with its mass. The air or fluid surrounding the object is heated, and it then moves away from the heat source and carries energy with it. The ideal gas law, most commonly written as PV equals nRT, where P is pressure, V is volume, N is moles, R is the ideal gas constant, and T is temperature, can be written using the formulas for density, D equals M over V, and moles, N equals M over molar weight. The ideal gas formula then becomes D equals P times MW over R times T. This means that density and temperature have an indirect relationship, so as a substance gains heat, its density decreases. This can be explained by the laws of chemical kinetics, which states that as temperature increases, so does kinetic energy, so the speed of molecules increases, and the space between molecules increases, leading to a decrease in density. This warmer water rises to the top because of its lower density and causes the movement of other substances with it. Watch in this demonstration how, as the candle is placed on one side of the tube, it causes the food coloring to move in the opposite direction because the candle is causing the heated water to rise, which then pushes the water in the other direction. And then, when the candle is moved to the opposite side of the tube, the water on this side is now heated, which allows the color to reverse direction as the new water rises to the top.
The air circulation in convection ovens makes things cook faster. Wow, that was fast.
Thanks, convection.
Oh, hey, didn't see you there. Now on to radiation. Cool. Oh, hey, didn't see you there. Don't mind me, I'm just soaking in some radiation. But don't worry, I still got my SPF 30.
Radiation is the third kind of heat transfer, and unlike convection and conduction, it has no medium at all. All life on Earth depends on the transfer of energy from the sun, and this energy goes from the sun through empty space or nearly empty space to the Earth. All of this is known as the energy transfer heat, since the sun's temperature is a lot higher than the Earth's. Radiation contains a factor E that is called emissivity. Emissivity is a number between 0 and 1, and the darker a surface or object is, the closer the emissivity is to 1.
and the shinier or lighter the object or surface is, the closer the emissivity is to zero. Basically, the value of E depends on the temperature of the object. And by knowing all of this, we can conclude that a good absorber is also a good emitter. The sun is a source of energy that has to have its own equation because of how much energy it emits. The heat of the sun is calculated by knowing that 1,350 joules per second per square meter of area at right angles to the sun's rays of energy hits the Earth's atmosphere. Now that's a lot to comprehend, so in short, this equation is known as the solar constant, which is 1,350 watts per meter squared. The atmosphere of the Earth is capable of absorbing 70% of this energy before it reaches the ground, depending on how many clouds there are, and on a clear day, about 1,000 watts per meter squared reaches the Earth's surface.
The Stefan Boltzmann constant is used to measure the amount of heat emitted by a black body. A black body is a surface that doesn't reflect heat. The value of the Stefan Boltzmann constant is approximately 5.67 times 10 to the negative 8 watt per meter squared per Kelvin to the fourth. Thermography is the study of heat observations in different regions. A thermograph is a special instrument that is used to measure the intensity of radiation, and this forms a picture that resembles an X-ray. Many things like tumors can be detected using a thermograph because of the tumor's higher temperature and increased radiation.
Whoa, get away from there!
But I'm watching my food.
Didn't you know the sun isn't the only thing that gives off radiation? Microwaves do too, and radiation is bad for you.
Thanks. I didn't know that. Now I'm gonna go watch my food.
Oh hey, didn't see there. Is it that time already? Well, thanks for tuning in to our super special segment on heat transfer. Convection, conduction, and radiation are something we use in our everyday lives, and hope you learned something today. Good luck on that quiz. Oh, and up next, America's Got Talent.